Alright, logic fans, what's up? Welcome to another video. Today we look at section 6.4 of the text, Quantificational Syntax for. Here we introduce the rule of inference, existential generalization. Let's rock. Okay, so just as universal instantiation sort of detaches a universal quantifier and universal generalization attaches a universal quantifier, we have a similar pair of rules for the existential quantifier. Existential generalization, which we're going to cover now, attaches an existential quantifier, whereas existential instantiation detaches an existential quantifier. So everything sort of proceeds in that sort of parallel fashion in that respect, but the nuances to the rule, there's little nuances to the rules like EG versus UG because of what you're doing, right? To infer everything requires certain circumstances, very special circumstances in the case of universal generalization, whereas if you're just inferring at least one thing as a certain way, in the case of existential generalization, the conditions are considerably weaker. So let's jump in here, and the first thing I want to draw our attention to is that the same classical assumptions that we covered in 6.2, so you can look at the video for that or the text to 6.2 where that was covered, are in play for all of these rules, UI, UG, EG, which we're covering today, and in 6.5, EI, existential instantiation. All of these classical assumptions are in play. And in particular here, if I can remind us that we're assuming a non-empty domain. So, for example, if we look at an argument like this, which we are going to be able to prove is syntactically valid, you might look at it from a semantic perspective and think like, hold on a second, this argument isn't valid. Suppose the empty domain. On the empty domain, the one and only premise here is true. It's vacuously true, right? And on that same empty domain, there exists at least one thing that's F is going to be false, right? So there's a semantic interpretation that shows this argument semantically invalid. How on earth could it be syntactically valid? These things have to coincide. Well, when it comes to syntax, we make the classical assumption that there's a non-empty domain in play. At least one thing exists. And so this will be deducible for us given our classical assumption. And similarly for the other two assumptions, okay? It's really important that you bear these in mind. Otherwise, you can be like, wait, how is that sort of valid? How can this be syntactically valid? It's not semantically valid. And, it just really helps to bear these in mind. So what I want to do now is just sort of informally motivate the rule EG, existential generalization, and think about what you're doing. You're attaching an existential quantifier. So you're going from a sentence like this to a sentence like this. And let's just think about what's involved with this intuitively, right? Here you're saying the particular thing S has the property G. So S is good, let's say, okay? Maybe S is a piece of chocolate or something. And you're concluding, therefore, at least one thing is good. Now notice, whereas the premise references a specific thing, right, in light of our classical assumptions, you're saying this particular thing, S, is good. Here in the conclusion, which you can absolutely do, and which existential generalization allows, you're not talking about any particular thing. You're saying at least one thing is good, and that is consistent from a logical point of view with all kinds of domains. It's consistent with a domain with infinitely many objects. It's consistent with a domain with only one object, with two objects, with three objects. It's consistent with there being 10,005 things in there that are good. It's consistent with there being only one thing that's good, okay? So this conclusion here, there exists at least one thing that's good, existentially generalizes from the particular, right? And it's saying, so something is good, and it's a way of speaking generally without referring to a particular thing as you do in one, and that is the essence of existential generalization. So what we have here is our first deduction involving existential generalization. You've got your premise, and then you just use EG like this. I'm going to state the rule formally, and we're going to look at lots of examples so that you understand all the aspects of the rule. But that's the essence of existential generalization. Okay, so prior to formally stating the rule, e.g. existential generalization, we need to review really quickly and sort of introduce actually the concept of an existential pseudonym, because the rule e.g. is stated in terms of them and with reference to them, and so is the rule EI, existential instantiation. Now recall that the concept of a pseudonym was initially introduced in section 6.2. So we use the letters A, B, C through, not through Z, through T to be individual constants. And that's fine, and we can attach subscripts if we need to, A sub 1, A sub 10, C sub 102, okay? And same thing with the individual variables. Sometimes we can even use W if we want, yeah, we can introduce the subscripts if we need more, okay? And this way of doing business sort of left U and V open, and U was the universal pseudonym, or U sub 1, U sub I in general. V sub 1, V sub I are the existential pseudonym. And the universal pseudonym was a sort of way of speaking generally about everything without saying everything. So, we could say things like the arbitrary triangle, call it U, contains 180 degrees. And if indeed U is sufficiently arbitrary, we can then existentially generalize from this, from U contains 180 degrees to everything, or every triangle contains 180 degrees, because it's sufficiently arbitrary. Well, the existential pseudonym fulfills a similar role, right, but not the exact same one. It's a little bit different. It gives us a way of speaking generally about at least one particular thing, not generally about everything in our domain, but at least one particular thing in the domain without specifying which thing. So suppose you got Santa's bag in front of you, and you know that at least one thing in it is good. At least one of the presents in there is a good present. But you don't know which one. You don't know if it's A. You don't know if it's B that's good. You don't know if it's C that's good. You might just say, something in Santa's bag, I don't know what it is. Call it V. That thing is good. And from that, we can make logical deductions, and that's basically the role of the existential pseudonym. It's a way of talking about a particular thing without specifying which particular thing you're talking about, okay? So with that, let's go ahead and introduce the rule existential generalization. Okay, so now let's state the rule existential generalization, work through some of it, just getting through it, and then let's look at some of these examples to make sure we're understanding all the aspects of the rule. So again, e.g., existential generalization, attaching an existential quantifier, is a rule of inference and not replacement. So where alpha is any individual constant or any pseudonym, existential or universal, and gamma is any individual variable. If you have a sentence like this in terms of individual constants or pseudonyms, you can attach the existential quantifier ex, backwards EX, backwards EY, backwards EZ. And then for this, where this is just sort of substituted in here, provided that X, Y, or Z, whatever you used here, does not already occur up here in this sentence, and provided what you have here, right here, results from what you had here by replacing at least one, but not necessarily every occurrence of alpha with gamma, and you make no other changes. So, same routine as before. Let's go through this and make sure we understand all the different things going on here. Pause now, go through these, and see if you can't figure out which of these uses of existential generalization are permissible and which are not permissible or impermissible, right? So here you have a premise, and here you have existential generalization applied to it. Is it permissible or not? Run through them all, and we'll come back and do them together. Pause now. Okay, hopefully you've had a chance to run through these, but let's go through here. Let's look at A. A is absolutely permissible. We saw that in the first example we opened with, where alpha is any individual constant. In this case, it's the lowercase a. You can do this, and you can go to Y, you can go to Z, you can go to X, because none of those occur up here. All right, let's look at B. B moves from, it's got an existential pseudonym in it, and it's got a not GA, and then existentially generalize on that, and they only replace the one. These are two different types here, and that's absolutely fine. This is totally permissible, okay, because it could be any pseudonym that you're replacing. All right, let's take a look at this case. Could we do this? Yeah, absolutely. Here we just left this alone, and then we changed this one, and that is absolutely fine. However, it's going to be one of our rules that you never end a syntactic deduction with a line containing a pseudonym, universal, or existential in it. So technically you would have to do another existential instantiation. Notice you cannot universally, or existential generalization, you cannot universally generalize to from a V. You have to universally generalize from a U. Okay, typically obtained from universal instantiation, the U will be. But yeah, so this is permissible to do as far as EG is concerned, but as a general principle, we don't allow our syntactic deductions to end with existential pseudonyms, so there would be at least one more step required here before this particular proof was finished. Okay, let's take a look at this one. This is impermissible, okay? Cannot do this. Unlike B and C, where you just sort of picked one and did it, here the person does it with both, and you're not allowed to do that. Alpha here has to be held constant. You have to pick one, okay? So you could do, this one and then a second one, right? So you could do the V and turn it into an X. There exists an X such that fx and not ga, and then you could existentially generalize to a y and get there exists a y, there exists an x such that fx and not gy. That would be permissible, but this is not permissible. Okay, you have to pick a particular alpha. Okay, now otherwise it would be qualifying as making other changes. All right, E. Here you have a universal pseudonym, and you can absolutely existentially generalize from a universal pseudonym, because this specifies any pseudonym, and since our classical assumption is that there's at least one thing in our domain, this is never going to be referring to something that's not in the domain. No empty domains allowed. Okay, here you've got the V in two places and you replace both of them. This says you have to replace at least one, but it is perfectly permissible by the rule to replace both. So F is permissible. That is perfectly legal, fair. Okay, let's look at this one. Here you've got a universal quantifier and you've got an existential inside of it, and you are absolutely allowed to replace it. I want to emphasize that you could not turn this to there exists an X, because the X already appears up here, which would be violating proviso A. Okay, let's look at H. Go ahead and take a look at that. Yeah, see, this is exactly what I was talking about with G. That is impermissible, not allowed, and it violates proviso A, where the X already occurs in this sentence, and so you would have to move to a Y or a Z in this case, some individual variable that does not already occur on the sentence you are existentially generalizing on. Okay, let's go ahead and look at this. Is this permissible? Absolutely not. That makes other changes, so it violates condition C here. Okay, FV, you've got an assumption here. Are you allowed to, from that assumption, do this? This is absolutely permissible. You can do this. There's no proviso about what happens with assumptions, as there was with universal generalization, and we will revisit that when we do CP and IP in Chapter 6 here. Okay, cannot do this. This is a rule of inference and not replacement. You cannot go inside this sentence and apply it here. The correct way to do it would be as you had here, and this is permissible because you only have to replace at least one occurrence. You don't have to replace all of them. So L is permissible as well. Okay, though again, you can't end a line in a syntactic deduction with the V here, so you'd have to apply another one to get it done. Okay, so Well done. This is a good start on this video. On the next video, the second video for 6.4 here, we're going to try to do some actual examples. We'll see you on the next one.